Calculating the final result for an experiment usually involves adding, subtracting, multiplying, or dividing the results of various types of measurements. Since it is very important that the uncertainty in the final result is known correctly, we have developed rules for counting the significant figures in each number and for determining the correct number of significant figures in the final result. Note that the number 1 times 10 to the second power above is written in exponential notation. This type of notation has at least two advantages. The number of significant figures can be easily indicated, and the fewer zeros are needed to write a very large or very small number. For example, the number 0.000006 is much more conveniently represented as 6 times 10 to the negative 5. To this point, we have learned to count the significant figures in a given number. Next, we must consider how uncertainty accumulates as calculations are carried out. The detailed analysis of the accumulation of uncertainties depends on the type of calculation involved and can be complex. However, in this textbook, we will use the following simple rules that have been developed for determining the appropriate number of significant figures in the result of a calculation. Note that for multiplication and division, significant figures are counted. For addition and subtraction, the decimal places are counted. In most calculations, you will need to round numbers to obtain the correct number of significant figures. The following rules should be applied when rounding. Although rounding is generally straightforward, one point requires special emphasis. As an illustration, suppose the number 4.348 needs to be rounded to two significant figures. In doing this, we only look at the first number on the right of the three. The number is rounded to 4.3 because 4 is less than 5. It is incorrect to round sequentially. For example, do not round the 4 to 5 to give 4.35, and then round the 3.4 to give 4.4. When rounding, use only the first number to the right of the last significant figure. It is important to note that Rule 1 above usually will not be followed in the example in this text because we want to show the correct number of significant figures in each step of a problem. The same practice is followed for the detailed solutions given. In the solution guide, however, when you're doing problems, you should carry extra digits throughout the series of calculations and round to the correct number of significant figures only at the end. This is the practice you should follow. The fact that your rounding procedures are different from those used in the text may be taken into account when you check your answer with the one given at the end of the book or in the solution guide. Your answer, based on rounding only at the end of a calculation, may differ in the last place from that given here as the correct answer because we have rounded after each step. To help you understand the difference between these rounding procedures, we will consider them further in example 1.4. The following values were obtained. P equals 2.56, T equals 275.15, and V equals 8.8. Gases will be discussed in detail in Chapter 5. We will not be concerned about the units of these quantities. Calculate R to the correct number of significant figures. The final result must be rounded to two significant figures, giving 8.8. The least precise measurement has two significant figures. To show the effects of rounding at intermediate steps, we will carry out the calculation as follows. Note that the intermediate rounding gives a significantly different result than the obtained by rounding only at the end. Again, we must re-emphasize that in your calculations you should only round at the end. However, because rounding is carried out at intermediate steps in this text to always show the correct number of significant figures, the final answer given in the final text differs slightly from the one you obtain. This is a useful lesson to be learned from Part C of Example 1.4. The student measures the pressure and temperature to greater precision than the volume. A more precise value of R, one with significant figures, could have been obtained if a more precise measurement of V had been made. As it is, the efforts expended to measure P and T were very precisely wasted. Remember that a series of measurements to obtain some final result should all be done to about the same precision.